Hi, science classes. I have pre-recorded notes that I'm going to be turning it over to in just a minute. I did want to touch on this week's objective. It's going to come up right here. This week, I can describe the types of plate movements and geological phenomena they cause. I can demonstrate understanding of Earth movement, earthquakes, and the damage it causes. So there's a set of earthquake notes, did some updates from what we had previously to make them review notes, and then of course you can follow through on the Quakes Choice Board. So if you're watching this, you probably already found the Quakes Choice Board. Best of luck this week. I'm going to turn it over to the pre-recorded video of myself.
Hey everybody, we're taking a look at earthquakes this week. So you can see we've got an earthquake happening here right below me. Little earthquake going on there. So let's go ahead and start it off. We are, you can have Bitmojis of me and actual me kind of both happening at the same time. So what should you know about earthquakes? Well, first of all, the study of earthquakes is known as seismology. So this seismologist is very lazy. He's studying from the couch, and if an earthquake comes, he's going to fall on the floor. Sorry, he was just studying seismology about falling on the floor. Now, the scientist is, of course, a seismologist. That is a scientist that studies earthquakes. These words are also available in the Quizlet that we had for this unit, and that is once again available during this review unit. Final thing you should know, vocabulary-wise, we got, of course, Bitmoji breakdancing here because a fault is a break in the Earth's crust. So those are going to be our key vocab words that you're going to want to know for this unit. Touch on those. Go ahead and keep moving. What causes earthquakes? It's, of course, the elastic deformation, which is when the rocks stretch further than they can handle and eventually break. Think about the rubber band being stretched as we see in the picture right down here. Guys stretching out the rubber band kind of like I might be doing like this if I had a rubber band with me. And if you stretch that too far, the rubber band will, of course, break. Breaking of rocks is called elastic rebound. The rocks release energy, and that energy causes earthquakes. Okay, so as we've got our chef up here, most earthquakes happen, of course, on the edges of tectonic plates. So he's holding up the big plate right above me here. Plates push, pull, and scrape against each other. The plates cause stress in the rocks, creating stress on the rocks and in the plates. So that's when they're going against each other like this. Of course, this specifically we'll touch on in just a minute. That's going to be your transform boundary. You could also have them coming apart like this. It's going to be your divergent boundary. We're coming together like this. That's your convergent boundary. Those will come back up in just a minute. Deformation is when the rock changes shape in response to the stress. Okay, so as I just mentioned, those boundaries, we've got the transform, earthquake will be shallow and moderate. The convergent, earthquakes will be strong and deep. And the divergent, earthquakes will be weak and shallow. So let's take a look at what those examples look like. Transform, remember trans means across. Should be somebody running across. There he goes. So he comes running across because transform boundary means it moves across. That's our, like this, side by side. Convergent boundary will be strong and deep. Remember, con means come together. Okay, so we got our yoga pose Bitmojis coming at each other. And then divergent, weak and shallow. Remember, div means apart. And yes, we are going to have our divergent movie poster pop back up here. Let me get Triss's way. There we go. Okay, so the seismic waves, the energy that travel through the Earth. There's two types of waves. The primary ones move towards each other, and the secondary ones move side to side. And that's why earthquakes, a couple of videos available to you on this week's HyperDoc. You take a look at those, especially when you're looking at the structural design videos. They talk about how earthquakes move in 3 different directions. That's what it's talking about with this, with your primary and secondary waves. They move in different directions from each other, and that's why it can be so difficult to build an earthquake-proof structure. So how do we measure an earthquake? Well, I mean, a seismograph. The seismologist is the scientist. Seismology is the study of it. The seismograph is the thing that actually tracks where the seismic waves have in fact hit. Now, let's of course not be confused about what an epicenter is. We talked about this a bunch. Epicenter up here on the top. Go ahead and circle it. It is the point on Earth's surface that's directly above the actual starting point, which is the focus down here. We can see our fault line is running just like this in this particular example. So the focus happens right where the fault line decides to actually have the rocks break. Right above that is the epicenter at the Earth's surface. Okay, so how do we measure an earthquake? We know that we measure it with a seismograph, but then the actual measurement is going to be the scale that was designed by a scientist named Richter. The Richter scale measures how strong the earthquake actually was. Can it be detected by only a seismograph? Is it a very light earthquake like a 2.0? Is it causing great widespread damage? It's going to be a 7.0, very strong. The Richter scale technically goes all the way up to 10. Very rarely see something that high. Usually things that are actually noticed and tracked and mentioned maybe on the news are going to be in this 5 to 8 range. I realize 8's not on our little thing here, but really it's going to be a 5 to 8 type of range we're looking at with where it would measure on the Richter scale. That is not on the test for this week, so don't worry about it too much. The damage, of course, can make buildings fall down or tip off scale, like we see with the buildings that are happening here in this picture below me. These buildings should be standing nice and straight up, and they're all leaning kind of in different directions. And so to prevent this, buildings are often made with added support structures. And again, that's something that's mentioned down when you get to the choice parts of your choice board, your hyperdoc for this week. There's a couple of videos that talk about structures of buildings and how they can handle earthquakes. Let's go ahead and take a look at that if you want more information. Not just buildings, though, they can cause landslides. So that's when rocks and mud or any other materials may actually come down off of a mountainside or a hilltop because of the earth shaking underneath them. That stuff can actually slide down. And then, of course, if they happen underwater, then they can create massive waves, which are called tsunamis. You can see this tsunami here is actually coming in and attacking the beach. I'm probably going to attack these beach resorts that are just behind that. So what happens in these cases? Well, in areas where earthquakes are common, builders have to take extra precautions to make sure that the structures will not collapse. They usually will tie the building walls and roof into each other as well as into the foundation of the building to try to make things stronger. Or they may, in fact, put in some reinforced steel or different kinds of designs to make things actually sit there. Occasionally, they'll even use buildings that kind of float, not like how they float on water, but they would kind of float on the pad, the foundation that they're on, to make it easier for the building to move around. And so, of course, they can be very deadly. Emoji's dead. There's an old saying that earthquakes don't kill people, buildings kill people. And that has to do with the fact that buildings have to be built to those codes to make sure that nothing's going to go wrong with the building and have it fall down and kill people. So I thank you for watching. Perfectly fine. Thank you for watching for this week. Hopefully you remembered some things you didn't remember previously about earthquakes, and you can do well on the assignments. If you run into any questions, of course, reach out to me. Drop-in hours are Tuesday and Thursday. You have the schedule for that, or you can always email me. Thanks so much. Best of luck on your earthquakes assignments.